Well, today's lesson is again complex numbers. But here I want to talk you about polar representation of a complex number. In early video, I talk you about rectangular form of a complex number. That means z equal x plus I y. Okay, you may remember this one. X, y both should be real numbers, and this one is known as the real part of the complex number, and the y with I value, this part is known as the imaginary part of the complex number. But today we are going to learn about polar representation. This is known as rectangular form of the complex number. Okay. Now, before I explain polar representation, I would like to talk you about little bit geometric representation of a complex number. Okay. Now, let's take example. Z equal 1 plus 3i. Z equal 1 plus 3i. Okay. So, look at here, 1 and 3 are real numbers. And using these values 1 and 3, Z can be uniformly defined, okay, using this 1 and 3. Now, if I write 1 minus 3i, this is a separate complex number. It has been defined using 1 and minus 3. So, using this property, I can explain about the position of this Z using 1 and 3. Using this ordered pair of coordinates, I am going to explain the position of this Z. Okay. If I draw two-dimensional plane, okay, this is the horizontal axis and this is the vertical axis. Okay. Now, using these two axes, I can represent this real part and imaginary part of a complex number. Okay. So, all the points on this horizontal line going to represent for real numbers, and all the points lie on this y-axis, vertical axis, represent imaginary points. Okay. Now, look at here 1 and 3. Those two are the coordinates I am going to consider for this complex number. Then you can identify this 1 is for real. So, 1 on real axis and 3 on this imaginary axis. Okay. So, from this one you can write Z. This should be the point to represent complex number Z. Okay. So, if you consider this one, what is the ordered pair for this one? 1 and minus 3. So, you can get, if minus 3 is somewhere here, this complex number represent on this point. You can understand this one. Now, using this property, we can represent any complex number on this plane. This plane is known as the complex plane, or sometimes it is known as Argand plane. Okay. Now, let's talk about polar representation. And if I draw another plane and look at here, there's a point P and O is the origin. Consider the distance from origin to this point P. Okay, there's a distance. If this point P represents a complex number, that means this distance means the modulus of this complex number. In my early video, I explained you what is the meaning of the modulus. So, this is known as the modulus of the complex number. So, let me write it as R. So, this is the modulus, and I am going to write this angle as theta. Okay. Now, look at here. If I complete a right angle triangle here, this horizontal distance represent the x coordinate of this point P. Okay. And also this height represent the y coordinate of this point. Okay. So, I can write this one as x o y, or look at this one. You can take x as r cos theta. Okay. Now, what I want to write is, I want to write both x and y using this modulus and also theta. Okay. So, x I am going to write as r cos theta and y as r sine theta. So what about point P? You can write point P using this coordinate, r cos theta, r sine theta. Can you understand? So try to compare these two. Here the coordinates of this point was 1 and 3. 1 and 3 is the ordered pair of the coordinates of this point. Then what was the complex number represented by this point? It was 1 plus 3i. Okay, 1 plus 3i using the coordinates. If you consider this point P dash, coordinates here are 1 and minus 3. So what is the complex number represented here? It is 1 minus 3i. So if the coordinates of x and y are r cos theta and r sine theta, what should be the complex number here? So that complex number you can write as using x coordinate r cos theta and using this y coordinate I r sine theta. Got it? Okay. So Z equal, here you can write this one as r cos theta plus I sine theta. Can you understand? So this format is known as the polar representation of a complex number. Okay, now let's look at Z equal x plus iy. Okay, I'm going to explain again polar representation for using x and y. Okay, Z equal x plus iy. So I'm going to convert this one into polar representation. So for the here, consider Z is not equal 0 and both x and y are real numbers. Now I'm going to rewrite this one as x squared plus y squared x over x squared plus y squared plus I y over x squared plus y squared. I wrote this line like this. Why? There's a reason for here. So look at here, Z equal x plus iy mean on the plane there's a point P to represent Z. Definitely the coordinate should be x and y. So x and y mean if you complete a right angle triangle here, this one x and this vertical height is y. Okay. So if this is theta, you know the modulus of this complex number becomes x squared plus y squared, root of x squared plus y squared. Okay, that's why I rewrite this line by dividing and multiplying root x squared plus y squared. Okay, so look at here, Z equal, this one if I write as r, this modulus of the complex number I'm going to represent using r. Okay, so here it is r. And this one you can write as x over r plus I y over r. Okay. Now try to compare these values with this triangle. Okay. X over r. What does it mean? X means adjacent side for this angle and r represent the hypotenuse. So x over r, this one represent cos theta. Okay. So you can write this one as cos theta. Then what about y over r? Y mean opposite side of the triangle, this angle, and r mean hypotenuse. So this is sine theta. So Z equal r cos theta plus I sine theta. So that's what I explained. This is the polar representation of a complex number in this format. Okay. So let's talk about an example. If we consider Z equal root 3 plus I. Okay, I have written an example for complex number root 3 plus I. Okay, I need to convert this one into polar representation. So Z equal, then what should be the value of r? Okay, according to root 3 and 1, the value should be Root 3 squared, but 1 squared root. Value is 2. So you are going to multiply by 2 and divide again by 2. Okay. Now root 3 over 2 and 1 over 2. Both are positive values. So this is in first quadrant. Okay. Now by looking at this complex number even, you can decide what is the quadrant it belongs. Because look at this one. X is a positive value and y is also a positive value. If both x and y coordinates are positive, this point P should be in first quadrant of this plane. Okay. So if this is negative and this is positive, what does it mean? Negative x coordinate with positive y coordinate. Then it should be in second quadrant. Can you understand? So if both are negative values, both x and y are negative. So this point should be in third quadrant. Okay. So here look at this one. You have got positive value. This is in first quadrant. So according to these values, root 3 over 2 and 1 over 2, what should be this theta value? You can decide it. Okay, I am going to write this one as Z2. What is this value? Cos 5 over 6. Because cos 5 over 6 equal root 3 over 2 and sin 5 over 6 equal half. Okay. So I am going to write this one as this way. Okay. Now this is special thing that I need to explain you. Look at here, I told you this R represent the modulus of the complex number. Okay. Here R is the modulus. Then what about this theta? This theta value mean the value here with the horizontal axis and also with the modulus. Okay, the angle between modulus and the horizontal axis. This theta is known as the argument of the complex number. Okay, theta is known as argument of the complex number. Or you can write this one as arg z. Okay, remember this one, arg z. I'm going to explain few minutes later. There's a difference if you write capital A here. Okay, so I wrote simple A, arg, arg z equal theta. Now look at here. This is theta value, argument. So what should be the argument of z? Argument of this complex number? It is 5 over 6. Is that the only argument value? Okay, is that the only angle we can consider for these values? Okay, now let's talk about little bit more about the argument. Okay, now I explained you theta is known as the argument of a set. Okay, now look at this one. If there's a point P to represent a complex number Z, let's take this angle as 45 degree or 5 over 4. Okay. Now, is this the only position, only angle value we can consider for this position? Then you have to think about this one little bit. Look at this one. I am going to take another 2-5 rotation. Okay, what about if I take another anticlockwise 2-5 rotation? Again, I will come to the same position. Then what about another rotation? Again, I have come to the same position. Okay, what does it mean? Look at this one, 5 over 4 plus 2, 5. Truly, it is 9, 5 over 4. The same position indicated by this angle also. If you take another rotation, that means 4, 5. So, again you will get the same position, 17, 5 over 4. Then what about in the other side, in the clockwise rotation? You can take here minus 2, 5 also for this same position. What does it mean? This position consists of infinitely many angle values. Okay, so you can't just take this angle as the theta value, argument of Z. If I write simple A, It means you can consider all the angle values corresponding to this position. So look at your previous example. It was root 3 plus I. Okay, I proved that this corresponding to the complex number 2 cos 5 over 6 plus I sin 5 over 6. Okay, but truly speaking, this 5 over 6 is only one angle corresponding to this complex number root 3 plus I. So if I write the argument 5 over 6 plus 2n 5. Okay, n is an integer. Can you understand what's the reason of writing argument of set like this way? This one, by adding multiple of 2 pi, you can represent all the angles values corresponding to this position. Okay, so when you use simple a, you have to remember it represents all the angles corresponding to this. Because of that, there's a special definition for argument. It is known as principal argument. Principal argument of a complex number. Here, it is represented by ARG, capital A. Okay, this one is only for this principal argument. This theta is between, theta is between -5 and +5. Okay, can you understand? Look at here, look at the inequality sign I have put here. Only less than sign, there's no equal sign, and here there's an equal sign also. What does this mean? Look at here, if you consider -5 from this horizontal axis, -5 means you are taking this rotation here in this direction, +5 in this direction. That means when you use this range, it represents only a single value that we can consider for a particular position. Can you understand? So when you write capital A, it just represents a single position of an angle. Okay. So for previous example, ARG root 3 plus I. I'm going to write the principal argument for this complex number. It is just 5 over 6. Can you understand? Okay, let's talk about another example. Okay, one more example to find out the argument of a complex number. Okay, look at this one. Z equal -1 minus I. Okay, so if you consider this is as a rectangular form, you can identify x is -1 and y is -1 again. So if you consider the ordered pair of the coordinates of this complex number -1, -1. What does it mean? The position for this complex number is in the third quadrant. Okay, so it should be in third quadrant somewhere here. Okay, now look at this one. I need to convert this rectangular form into the polar representation. So Z equal, what is the modulus here? This one was -1, -1. Okay, let's represent this one on the plane. Okay, if P is the point to represent this complex number, coordinate should be -1, -1. Okay, so actually this complex number you can represent in third quadrant. Okay, so what about this modulus? It should be root 2 because this is 1, this is 1. Okay, this one should be root 2. So this one root 2 into -1 over root 2 -1 over root 2 I. Now According to these values, you can identify what is the angle. Now you know, now already you have found this is in third quadrant. And this angle should be 5/4. You can write this angle if you consider in anti-clockwise direction, that is 5/4, or if you consider in clockwise direction, that is minus 3/4. Okay, so I am going to write Z as √2 cos minus 3/4 plus I sin minus 3/4. Okay, so now you know about this simple A representing argument using simple A and using capital A. You know the meaning, the difference of these two. I am going to write these two. Now if you consider this one, argument, you have to represent all the angles corresponding to this position. So I am going to write argument of this Z as minus 3/4 plus 2n/5. N is an integer. Okay. Now what about this one? This is principal argument. So I am going to write this one just as minus 3/4. Can you understand? Okay. Now in this example, I explained you how to convert a complex number into polar representation. Now you can do in other way also. That means when you have given a complex number in polar representation, you can convert this one into rectangular form. I will do one more example for that. Okay. Let's consider Z equals 7 cos 60. 5/3 plus I sin 5/3. Okay, let's consider about complex number in polar representation. Now look at this one. You can write a Z equal, this is R. That means modulus of this complex number is 7. Okay, you can write this one as modulus. So if you consider this one, if you compare this one is R cos theta plus I sin theta, this is the modulus. And what about this theta? This is the argument, that is 5/4. Okay. Now, if I represent this complex number on a plane, modulus should be 7 and argument is 5/4, 5/3. So, P is somewhere here. It should be 5/3 and this is 7. So, you can understand, you can find out easily what is the horizontal distance and the vertical distance to this point P. Okay, this one, if this is X, this is Y, you can identify easily using this angle and modulus. So, consider this one as cos 5/3, it should be X/7. Okay, so X means 7 into half. And what about Y? Y means 7 sin 5/3. That means 7√3/2. So you can write down this Z as, if X and Y are 7/2 and 7√3/2, using these two values, you can write Z as 7/2 plus 7√3/2i. Okay, so you can write this 1 plus √3i. Okay. So this is the rectangular form of this complex number. So I think you can understand what's the meaning of polar representation. Especially you have to identify the argument. Okay, I explained you when you use simple A for ARG and capital A for ARG, that it has two different meanings. Okay, so try to do more examples, more exercises using these examples, then you will be able to understand. This is not much difficult. Okay, thank you.